Hi, welcome everyone. My name is Sandra Ahlgrimm and I am a cloud advocate working for Java at Microsoft. And I'm here with Julien Dubois. He is leading the Java advocacy at Microsoft and he's also the father of JHipster. Today we want to take you from zero to hero, so with no code, nothing at all as a starting point, to a fully running app, like a real-time app with like everything. You have the front end in Vue.js, you have the back end in Spring Boot, and you will also have the database connection with PostgreSQL, as well as managed access with Azure AD. We'll also have a look at scaling and the CI/CD pipeline. So Julien, you're the father of JHipster. What is JHipster? What can I use it for?
Hi, so thank you, Sandra, for introducing me and JHipster. So JHipster is code generation tool that I created about 7 years ago. It's made initially for Spring Boot apps. It's doing much more today, but I mean for this demo, we're going to use Spring Boot. And so you can go to JHipster.tech, and on JHipster.tech, well, you've got lots of information about JHipster. The most important thing to do is to go to something that we call JHipster Online, and JHipster Online is a simplified version of JHipster where you can generate your application graphically on the web. So here I'm clicking creating application, and I'm going to say I want to create an application in my GitHub account. I'm going to call it J4K demo, and oh sorry, I can't have special characters, of course. I'm going to generate a monolithic application, and this application is going to use a database, which is PostgreSQL by default. It's all basically, I'm going to use all the default settings from JHipster because our goal today is to deploy this to Azure Kubernetes service. So I'm basically using a normal JHipster application, a normal Spring Boot application using Vue for the front end. And here, well, you just click on generate on GitHub, and this is going to generate the application for you on GitHub. I've already done it here. I've already done the repo. Here it is. If you want to have access to it and look at our code, well, you just go to gdubois/2021 J4K demo, and you will see our code. As you can see, it was generated by JHipster, and there was like nothing specific. It's a normal sample application. Starting from this, we want to deploy that app to Azure Kubernetes service. So what do we do? Well, first thing we need to do is create a Kubernetes cluster on Azure. For that, well, you've got many different ways to do it. The easiest one is to go to the Azure portal. I'm going to look for Kubernetes here, and well, I can create my Kubernetes cluster from here by clicking around. This is good when you're getting started, but it's not easy to repeat that process. Here, for the example that we're doing, we need a Kubernetes cluster, we need a PostgreSQL database, we need also a container registry. So that's quite a lot of things to generate and to code. So you can click around, but I would say experienced people will automate this with some tooling. On Azure, we've got two standard tools, which are called ARM and Bicep. And a lot of people are using a third-party tool, which is called Terraform. And this is the one that I'm using right now. For this, I've created recently, well, with some friends from Microsoft, we've created a new tool called NubesGen. If you go to nubesgen.com, you've got everything to deploy a Java app, typically, to Azure using Azure Web Apps or Azure Functions. There is not Azure Kubernetes service yet, but we're working on it, and I'm here using a preview version. So I've got Kubernetes service available here. And by using that tool, I was able to generate, so if I go back to my app here, this Terraform templates, which are available here. So if you just want to use what we've generated, just fork my repo, and you CD to that repository, and you can have a look at what we generated here. It's pretty standard. If you go to modules, we've got one module for Kubernetes service, one module for PostgreSQL, and inside Kubernetes, we've got the Kubernetes cluster and the container registry, which are getting created. So if you have a look, it's, I would say, pretty classical Terraform stuff. And once you got that, well, you can just go to your repository, CD Terraform, and you can say Terraform init to init your repository, and then Terraform apply, and this will apply the Terraform configuration to your cluster. So once you've done that, I've already run it because it's going to take about 5 minutes. This is going to create for you automatically a resource group. Let me just click here to fetch the resource group. And inside that resource group, here it is. Inside that resource group, we're going to have 3 resources. One, which is the Kubernetes cluster, here it is. One, which is the container registry. And the third one, which is the PostgreSQL database. So now we've got all those resources created. Well, all the work we need to do is take our Gipster app, package it as a Docker image, push it to the container registry, and then have the Kubernetes cluster pull it from the container registry, configure the PostgreSQL database, and have everything running together. That looks a little bit complex, so let's have a look at all of this. Let's start first with the Docker image. I'm opening this up in my IDE. And so in my IDE, let's have a look at how we generate a Docker image with Gipster, and let's discuss how we can improve this. So on Gipster, you need to go to the pom.xml and have a look at something called Gib. So Gib is a tool which is originally made by Google, and Gib allows you to generate Docker images without a Docker daemon. So that's why I like it. I can run it locally without a Docker daemon available. It's also sometimes interesting in some CI/CD platforms where you don't have Docker available. And what this is doing is that this is taking a base image. So I'm using the new OpenJDK build from Microsoft. Let's discuss this later, but this is very interesting. And from that Docker image, I'm adding some configuration to add my Gipster app inside the Docker image and publish it to my container registry. Sandra, because I know you're a Kubernetes and Docker expert and you are much better than myself on containerization. What do you think about Gib, and do you have some alternatives or better options to use it?
Oh, I wouldn't call them better options. I think if you're using distroless images, you're already very, very close to how to use it the best, because what you want to have is the smallest Docker image as possible, because then it not only saves you time in deployment, but also gives you a less security surface area, so they're probably more secure. And yeah, as I said, they're also much smaller. And what I also feel is that you have very well defined layers in place, so you can reuse the content that doesn't change too often, because then Docker can use the cache of it, and then only the changes, which are probably code changes, will have to be rebuilt and also be pushed and pulled. So you can have a look at the Docker Registry, because we already pushed this one, if you want to see the layers of yours. So maybe you go on the portal and then check out your registry. Yeah, I see you're doing it right now.
I'm clicking on it.
And then you have the repositories right here. And here you can see your different images which had been pushed to the registry. It's a private registry here provided by Azure, but it can be any Docker registry. And here you can see all the layers. And you could also pull the specific image with the command provided there.
Oh yeah.
If you're doing it right now, you will probably get an error because you don't have the PostgreSQL in place, as we had to give it access inside our Kubernetes cluster. So then what you could also do is, if you have another application and you have the Dockerfile, which is probably the starting point, especially if you do it manually, you can create your own Dockerfile, which we did in a branch. So you can have a look in Github, for instance, or also in the portal, but we'll have a look later. So here is the GitHub. And here you can see it's a classical Docker file. We haven't optimized it much. So for instance, you have the OpenJDK Alpine build to make it, as I said, as small as possible, which is copying everything inside and then running without the test, because it's just a sample app we just generated from JHipster, so we don't have to run the tests. Don't do that in production. You will probably need the tests. And then we're just copying the target folder here, especially, I mean, in my fork, you will see that you can also just copy the jar file, but here it's fine. We have the the target folder, and then we're just using the JDK Alpine. You can discuss that the JRE Alpine is probably good enough for you, so you can make it even more small, but here it's also fine. We have the multi-stage build in place, and you can just entry it with the Java demo app command here. And if you have the Dockerfile in place, it's like, then it's not very language specific, right? So we don't care if it's a Java app underneath or a Go app or a JavaScript app. So that gives us opportunities and advantages on the Kubernetes side of you. So now we can go into the portal and check out on our cluster. Because I think Julien has forgot to mention that we also use the GitOps possibility with NubesGen, which generates then our GitHub actions for us. But we can also have that, yeah, you can have a look here. We have the GitOps YAML, and this one was generated by NubesGen. We'll look at this later. You can also have it in place if you go to the portal and then click on the DevOps. Here is Deployment Center. That's how it calls. It's in preview, but already there. And here you can just specify where your code is, and then you specify the path to your Dockerfile. And as you can see, we have everything here. You can also use an external Git provider, so your own one, or Bitbucket, or GitHub, or GitLab, whatever is yours. We are authorizing it. The cool thing about authorizing it, and then you need to specify the repository and the branch that can find the Dockerfile. That allows you also to use like different branches for like dev staging test environments, and then you can deploy it to your specific namespace in Kubernetes. And here you specify the port. We know that as all JHipster apps, this one is also running on 8080 inside, so we specify this here, and you can also see again the Dockerfile which we are taking here. Okay, now we can click on next. The Docker build context, we just left it as it was because we think that everything that is in the folder is important for our deployment, but if we don't need that, we can even reduce the surface here and make the build faster. So here we have the opportunity to use an existing namespace, or we create a new one. That's very handy. So we already have a deployment with the NubesGen generated GitHub action, but we can also generate a new one and then use another namespace. So we can just use the same one, and we can use the same container registry, or we create a new one. So, and Kubernetes, I don't want to cover the basics here, but you know that Kubernetes, you have your namespaces, and you can even divide your application stack by namespace. So you can give a specific namespace, CPU, and memory, and make sure that they won't interfere with each other, so they're very separated, and your front-end app from staging wouldn't steal the resources of the front-end app in production. But sure, if you want to have them totally separated, you can also span it across multiple clusters. So now if you go on the code on GitHub, you will see that there is a new commit on the branch, probably. There you see it. And then we can have a look what Azure did here. And it was also generating the secrets in the settings, so everything that GitHub needs to know to be able to do the whole CI/CD push to Azure was generated for us. So we need to have the access tokens and so on.
Yeah. Oh, sorry, it committed with my account. That's why I couldn't find it.
Yeah, that's fine. It's just we can see that now the workflow file was automatically added for us. And here you can also see the secrets, username, password, and everything. So that's working fine as well. And it also created, what's very interesting, if you go down again, it also created the manifest files, the deployment YAML and the service YAML.
Oh, yeah, so that's the thing where it's really, really useful, because so here we had basically two ways to do it. It's either using Gipster with Gib, which generates the Docker image, but we don't have a Docker file. So everything that Sandra showed cannot work because we don't have a Docker file. And with Node.js, we generated our own GitOps workflow to deploy. So first solution, Jib with this workflow that you create manually. And second solution from Sandra is you create a Dockerfile, and then you benefit from that automatic workflow to deploy your app. Both are good. It's a question of choice. The very interesting part of what Sandra did is that that generated those manifest files for us, and those manifest files are a little bit complicated to do. Let's have a look here on my repo, on my branch. I've got 2 of them. I created both of those YAML files. I'm a Java guy. I'm not used to that. Well, I mean, several decades ago, we had the deployment descriptors in Java, egbjars.xml, that kind of things. Here we're having them again in YAML. Can you tell me a little bit more about those 2 files, Sandra? What is this file for example?
Yeah, sure. So this one is a deployment YAML, and in Kubernetes, we do everything with YAML files. So we have our deployments as well as secrets, and you can have everything, as I said, in deployments. And here we have the one for our app deployment. So you can see we want to have resetting the spec. So we have one app running here. We are giving it a label that's needed to view it later on. Also in the logs, it makes it more handy. We are also giving it the container image. So here we are also defining the latest tag in the end. This one is a bit optional because if you don't have a tag there, it will always take the latest one. And we'll give it a name. And very important here is the container port. It's set to 8080 because it's inside the container. It's running on 8080. We can also specify environment variables here, which is, for instance, the Spring profile. So we want to have the jar file generated, so we use the port one. And we are also giving it the Spring data source password. And here you can see we are passing the key, and this one is also an environment variable because we want to use it as a secret here.
Yeah. We'll detail this just a little bit later when we configure PostgreSQL, but that's going to be very important.
Yeah, and then in the service YAML. And here, what's very interesting, we are setting the load balancers, so an ingress. And here you can specify that if I want to access the web page, I'm a user and I don't want to specify any ports, so it should be 80. So I can set here that it's outside, it's 80, and inside the container, it's 8080. Which makes it more handy for everyone to use. And it's selecting the app J4K demo, so the one we specified earlier.
Okay, so quite a lot of configuration, but once we've got those, it's going to be able to deploy our Docker image on the Kubernetes cluster. So let's just have a look at our workflow here. So it's a GitHub Actions workflow that is going to be executed each time somebody pushes something on the main branch. And so if you have a look at that code, what we're doing is we're building our image with Jib. We are logging inside Azure. We are pushing that image to the Azure Container Registry that we created before. So we need to log into that Azure Container Registry and push that image. Once this is done, we are setting up a Kubernetes context. Basically, we need a namespace where we're going to deploy. We create some secrets. So here we are creating 2 secrets. So that first one is mandatory. It's a secret that we're going to use to pull our Docker image from the container. So that allows the Kubernetes cluster to have access to the Docker image that we just created before. So that's how we will access it. That second one, it's a specific secret that we created for the database password. So we just talked a little bit earlier about this. Let's detail this a little bit later when we arrive to the database, but that's going to also to be very important. And once everything is done, while we're deploying everything to Kubernetes, we've got a specific GitHub action for that. And we give it the 2 manifests that Sandra described. We give it the Docker image that was pushed before, and we've got the credentials to access it. And that's it. Once you've done that, everything is going to work.
Can you prove that? So shall we do a minor change and then you git push it?
Yes, let's do a change. I don't know. Let's change in my app. Let's change some hello world is here. Like I'm going to say hello, Sandra. Yeah. And I'm just going to git push it. Sorry, I didn't commit it. I'm going to git push it. If my IDE works, okay. Hello. So this is going, of course, to commit my code to my main branch. This is going to trigger my GitHub action, and it's going to do everything that we've described before. While this is running, let's have a look at the last thing that we didn't describe. It's the database access, because we need a database, and the database is not running inside Kubernetes. It's a managed database from Azure. It's called Azure Database for PostgreSQL. We created it using, I don't want code analysis.
Yeah, remember, containers are usually stateless, so you don't want to have your data in containers, only for testing purposes probably. So if you are production grade, you want to use like special services which are like geo-redundant and do have load balancers who are secured. So we're using the proper service here, which is the Azure PostgreSQL server.
So here is the Terraform script to create that PostgreSQL database. And if I go to my Azure portal and go to our resource group, well, we can see we've got that PostgreSQL database running, which is empty because we haven't pushed anything yet to it. Let me just go to the resource group. And we're going to see that PostgreSQL database very soon. Here it is. So what we need to do is connect our Gipster container running inside Kubernetes to the database, which is running outside of it. For that, well, if you have a look at our PostgreSQL code, Terraform configuration, sorry, you will be able to see that we open up the connection security here, and that the firewall is open so that Kubernetes can access the database. And let me push my code now. And well, let's have a look at the specific database configuration that we have here. The database configuration is in one file. If we go to resources config application prod, this is the production configuration from Gipster. Well, it's a typical Spring Boot configuration, so it's absolutely not specific to Gipster. And the key here is Spring, data source, password. Well, you've got also the URL and the username, but those are not secret. I mean, you can also put them as secrets if you want to, but there's like no real reason to put them as secrets. So those are hard-coded, but here the password is not hard-coded at all. It's going to be pushed to my app. And the way it works is that when I generated my PostgreSQL database, I copied the password. I put the password here as a secret in GitHub. So if we go to the GitHub secrets, we're going to see that I got a database password, which is a secret, PostgreSQL password. So this is where my password is secured. It's only written here. In fact, I deleted it everywhere else, so I don't know the password now anymore. It's just stored here. And when GitHub Actions run, it's going to use that password. Let's have a look at the GitHub. Here I'm creating a secret that's using, so I'm creating Kubernetes secret that uses the GitHub secret that is here, and it is pushing that secret into a specific variable, which is called Spring data source password.
Can you show the GitHub action?
Yes, this is a GitHub action.
No, you're showing the GitHub's YAML. I mean, on github.com.
Oh, you mean running?
Yes,
yeah.
Because it's running currently, so we can have a look. And here you also see the secrets which were automatically configured for us via the portal. But as we're using the JIP, which is the distroless image, so even better, we had to do this by ourselves.
Yeah, so this is building currently the image in Docker. Well, this is going to take some time, so we can go back there in a few minutes. But this is basically building the image. Once the image will be built, it will log in inside Azure, push that image to the Azure Container Registry, so set the context, create the namespace, create two secrets, so especially this one for the database, and then deploy it to Kubernetes. Yeah. Oh, sorry. One last thing we didn't talk about that secret is that it's being read by our application here. So if you go to our deployment YAML file, we can see that the secret here is being written by the deployment file and put into specific environment variables that then will be used by Jibster. Sandra, so that's something I've seen before, but I know this is not fully secured. Do you have any recommendation on storing secrets in Kubernetes to use them like what I'm doing now, but maybe something more secure than that?
So the issue with this one here is that everyone who has access to the cluster is able to get the secrets out of the Kubernetes cluster. So what you can use is a more secured way of storing them. There are services like from HashiCorp Vault, or you use Azure Key Vault for it.
Yeah, so so you have better options, but which are external to Kubernetes. So today we're only using with the standard Kubernetes stuff.
Yeah, Kubernetes secrets, but as you can see, it's not readable. It's not stored in Git, so it should be, for most of the reasons, it should be fine. But if you have like more applications, you probably want to go even more secure and also store all the secrets at one place and not being forced to go in each repository and add the secrets there, right? So you probably want to use Azure Key Vault or HashiCorp.
Yeah, and also for a human point of view, because here, so my secret comes from my GitHub secret. So that means you need to have the GitHub administrator who will manage that secret by himself. Maybe you don't want that person to be the one who manages your database password in production because maybe it's two different persons. Maybe you want to have some audit and here you can't do it. So it's a good way to work, but it can be improved. So in this example, so we take it again, so from GitHub secrets all the way to Kubernetes secrets, and we're pushing it to Jibster. But yeah, indeed, that can be improved. Let's have a look at our deployment. Well, everything is being deployed right now, so we're lucky. We can see that the image was built, the secrets were created, it was deployed to Kubernetes. And so now if I go back to my Kubernetes cluster, let's go to my cluster. We can go here to, we have access to our cluster. And here you can see I can click around and see many information about my portal. That's because I've already configured it, so I have access to it. By default, this will be secured. As you can see here, I'm using Azure AD to protect my portal, and I've got a specific user ID group that has access to my portal. So that's something I've done before. So in order to do that, let me just show you how you do that. You need to go to Azure Active Directory. You need to create a specific group. So I created a group that I've called Dubois Kubernetes. And
but I would probably have like my groups already in place because it's just the normal Azure Active Directory. So I would have like a group for developers and another groups for IT ops, or maybe even specific team groups for my applications.
Oh, yes.
And then I could just choose them and then give them access to the specific Kubernetes clusters.
Okay, so and here I've got a group where I'm the only person in it, but of course you can have more people in that group. It's a real group inside the Active Directory of Microsoft, which is cool. And so if we go back to my cluster, if you go to cluster configuration, I gave access to the cluster, to that group that we just discussed before. Here it is. And because of that, everybody has got access to that cluster and have access to the namespace, the workloads, and so on. If we click around here, we can see our namespace, and inside the namespace, you will have our Docker image running. Let's have it, let's view it running live. For that, I'm going to Services and Ingress. You remember we created a service.yaml file to open up our load balancer for this app. So if I click here, my app is running here, and we can see my app running in production on this IP address. And I can just go run my app and and play with it. Everything is running. It's connected to my database. It's running inside Kubernetes. So that's cool. But once I've done that, there's one last thing I would like to do. I would like to be able to scale that app. Sandra, honestly, I don't remember where to click. Where do I click to scale that app?
Yes, you go on settings and then on node pools, and then you can specifically click the nodes you want to scale.
So if I go to node pool, here it is. I've got node count here. I've got 2 nodes. And so if I want more nodes, I just do it like this.
Yes, but remember you pay per nodes. So be a bit...
Okay. So maybe I would like to use autoscale to have this automatic.
So you can even define a node count range. So if you have more traffic and more load and more memory used, it will scale up. And if it's not needed, it will scale down automatically for you. I would go for something between 2 because you always want to have replicas. So especially you will always need at least 2 nodes for your system running, and then you can scale it up to maybe 10 or something.
Okay, and I will apply, and that will scale automatically my cluster if needed, of course.
Shall we have a look at the monitoring as well?
Yes, where do I need to go?
Oh, you see, under the settings, there's also the monitoring one. And there you have application insights.
Oh.
And you need to enable it, but then it will work for you.
Yeah, I already enabled it. You need just to click on the button. So I clicked on that button earlier, I think.
Mm-hmm. And this one is collecting everything. Also, if you have Prometheus up and running, it will also collect the Prometheus data here and display it here. So you have the CPU utilization as well as basic things such as node count.
Okay, I have reports on everything. I can see my nodes.
And you can also set alerts. That's always very handy because you want to know what's going on your cluster, and you don't want to check regularly. You want to be alerted if something is going unexpectedly wrong or very good. You know, more traffic on your page is usually very good.
Okay. Well, thank you, Sandra. We're nearly out of time. So just to recap, so we created an app using Jupyter. We used a preview version of NubeGen to deploy it, to create a Kubernetes cluster. And then, we had a look at how to create a good Docker image using Jib or a Dockerfile, how we could deploy it automatically using GitHub Actions. Here it is. How you manage secrets, especially to connect to the database. And then how we could scale it and monitor it using AKS, Azure Kubernetes Cluster. Thanks a lot for all that information, Sandra. I hope
thanks, Julien.
Learned a lot.
I really love that we automated everything from zero to hero. We used JHipster as well as NubesGen, and then used the GitHub action for it. And remember, we also said that we don't care how the Docker image ends up in the registry. We just pull from there and then deploy it to production. So you can go with Docker files, or you go with the build packs, they're called in Spring, right? Or you go with the distroless Jib images.
Yeah. Thank you.
Thanks, everyone. Now it's time for your questions.